in geometry, let's call this lesson 12, eh? So that we can sort ourselves out. A little bit of geometry in between. The geometry lesson starts with telling you that we're going to be working in circles. Does that mean that you don't have to remember anymore that the sum of the interior angles of a triangle is 180? Or that when you've got parallel lines, we've got alternate angles and corresponding angles and co-interior angles. Or exterior angle of a triangle equals the sum of the opposite interior ones, etc. And lots and lots of parallelograms you did in grade 10. Are we still going to have to know that the opposite sides are equal and diagonals bisect, etc.? Not most of the time in geometry, but in analytical geometry, you're going to use a lot of that. So what I'm telling you is that nothing that you were taught is going away. Everything still has to be understood and known. In geometry as such, I'm talking about circle geometry, grade 11. You're going to have 9 theorems. And today I'm teaching you theorem number 1. Phenomenons that have come out of facts, if you have actually drawn it, like EGD, according to scale, etc. The first theorem says that, and now what do we call this thing of a circle? The center of the circle. Alright? What is it called from the center to the side? Radius. If it's a radius that goes through the center but goes right across to the other side, diameter. All with me? Alright? So what is this thing? From that side to that side, or if I do it over there? We call it chords, right? Because you need to know this stuff. We're also going to be talking later on about arcs. That's not Noah's Ark. An arc is a piece of the circle edge. So we're going to talk about the circle arc in some stages. Other stuff that we know, and it is in your textbook, you can go check, it's all there, that they've actually started there with the geometry, explaining to all this stuff. What I've drawn over there are 2 radii, radiuses, radii, that is subtended or underdrawn by a arc. But this is now called the chord. So the first theorem, let's just get one thing done today, is that if you take a line from the center of the circle, and there is a chord in the circle, now there's going to be complicated sketches that you're going to be handling in your life in geometry. So they won't only just be 2 or 3 lines. But the first theorem says, if I have a chord and I'm drawing a line from the center, not from anywhere, and it goes to the center of the chord. So in other words, what's given here on this sketch is, I'm coming from the center to the chord, and it must be in the center. So that's what that is. If my sketch is all in purple, that's all in pencil in your book. But what I deduct, just like last year in geometry, what I deduct, I do in another color pen. Do it in a highlight pen, then you're safe. So the deduction is, line from the center of the circle to the center of the chord will do what? It will be perpendicular to the chord. So you're going to know that this will be 90 on either side, obviously, because it's a straight line, and angles like that make up 90 and 90 is 180. That is the theorem. Luckily for us, we have abbreviations in geometry. You can just say sum of the angles of a triangle, right? Alternate angles, but keep in mind those parallel lines, like always. The abbreviation is, you don't have to say a line from the center of a circle to the center of a chord will be perpendicular to the chord. And I was writing there previously, from the center of the circle to the midpoint of a chord. Is that okay? Yes. You're not a parrot, you don't have to know it word by word like that. So in any of those cases, it will be perpendicular to. Now, if you use that theorem, you only need to write the line from the center of the circle to the center of the chord, and the rest will be what's in your sum. You're going to tell me, man, that's 90, and the reason is line from the center to the center. That's why you were writing it's 90 there. So you've got a nice abbreviation. So if you can just get the basics down of it, we'll do examples next time. Okay? So the converse, which is not a clothing make, converse of this theorem means the other way around. Now I'm giving you in purple, so that's in pencil, I'm giving you that it's perpendicular
grade 8I, please come to the office.
Mr. Mashego will be on the video forever. So if it's perpendicular, then these will be bisected or half-half, midpoint, split into two, halved. That's going to be your sum. So what will the words be? A line from the center of the circle, perpendicular to a chord, will bisect the chord. What do you think the abbreviation will be? Line from center of a circle, and you're allowed to do that, perpendicular to a chord. You're saying nothing about bisecting. The bisecting is the red part, you are deducting it. This is what the sum then says. So those are the two theorems and their converses, and next time we'll look at actual examples. Just so that you know there's two theorems. Actually it's one, but for the one it's given that's perpendicular, you deduct it's halved. Other one is given halved and you deduct that it's perpendicular. Okay.